we took a look at conditional statements, but we're going to need to iterate to solve a lot of different kinds of problems. And Python is like most other languages. We have ways to iterate using loops. So in Python, we have the while loop, which is the simpler of the two loops we'll use in Python. While loops kind of work exactly the way they sound. If you read them out loud, they kind of do exactly what that sounds like. So I is equal to 0 while I is less than 5. So if we run this, while I is less than 5, we continue to execute this code block. So I is going to start off as 0. I is less than 5. Yes, it is if it's 0. So we print it out and then we add 1 to it. Note that we don't have a plus plus. We only have plus equals 1. So if we want to increment I, we'll see this in Python quite frequently. So 0, 1, 2, 3, 4. And then when I gets to be 5, it's no longer less than 5. So we don't continue this loop any further. So we execute the statements within this block of code as long as this while loop statement continues to be true. So a while loop might never execute. If we run this one, you'll see I is equal to 0 while I is greater than 0. Well, we don't actually do anything because I is not greater than 0. So a while loop sort of works like an if statement there, in that, if this isn't true, then we never execute any of its body. Now, in Python, we don't have a typical counting style loop that you would see in C or C++ or C# or Java or JavaScript. This sort of for int I equals 0, I is less than something, I++. Python doesn't have this kind of loop. It actually typically is used for iteration over a list or string or some other type of structure. So we iterate, for example, for a string, we iterate over that by basically taking each particular character, we set that value to the variable letter, and then we print that out. So WORD, we set letter to W, we print it, we set letter to O, we print it, we set letter to R, we print it, and we set letter to D, and we print it. And when you're iterating in this way, this kind of for each way, you prevent some errors like kind of iterating forever. So because we don't have that counting for loop, we use a range function to sort of do the same thing. So range is going to, in this range for will give us 0, 1, 2, 3 all in order. So if we run that, you can see we get 0 and then 1, so we print out 10, then we get range 2, so then we print out 20, then we get range 3, we print out 30, and then at 4 we terminate. So range is a generator function in Python. Simply what that means is that it actually gives us values one by one instead of an entire array. And older versions of Python used to give, if you said range, 10 million, it would give you an array of values 0 through 10 million, but not including 10 million, which would be kind of a waste of memory. So generator functions work a little bit better. So if you need to start with a different value from 0, you just use two parameters. The first parameter is the start, and then the second parameter is where you end, but not inclusive of that. So range 10, 16 is going to give us 10, 11, 12, 13, 14, 15, but not 16. So you can see how that works. And you can also count in increments or other than 1. So you can count by 5s. So 20, 25, 30, so on and so on, but not 80. We don't actually include that one. And it doesn't have to come out perfectly evenly. So if we run this, you can see 12, 31, 50. Once we get past 61, we don't actually include that. So we start with 12, we go up to 61, and we increment by 19. And you can see 12, then 12 plus 19 is 31, then 19 plus 30, or 31 plus 19 is 50, and then the next one, we just don't include that. So to count backwards, you use a negative third parameter. So if we start at 10 and go backwards to 5, so you can see 10, 9, 8, 7, 6, and then we don't include 5, just even when we're counting backwards, it works the same way. Now, we can embed loops, we can mix in if statements, we can do all sorts of different blocks of code here. Here's a little bit block of code that will print out the prime numbers between 2 and 40, and we do that by looping through each one of these, iterating through each one of these values, 2, 3, 4, 5, 6, so on and so on. We're going to assume that value is true, and then we're going to use a second for loop, counting from 1 less than that number down to 1 by -1. And if that's divisible, then it's not prime. And then if we finish that loop and we say it is prime, then we will print that out, and you can see 2, 3, 5, 7, 11, 13. But this is actually going to be a little bit wasteful because once we determine a number is 5, or is prime, we can be done. So that's where we get into the break and continue statements. So break and continue allow us to exit a loop or continue to the next iteration of a loop, and we have those in Java and other languages. In Python, we have them as well. So here, once we determine a number is prime, we can break out of this for loop. So that break is going to terminate that loop immediately. Now this is going to give us the same result. It's just that now it's going to give us the result a little bit faster, because as soon as we determine that a number is not prime, we can finish that particular loop. And we can also use continue to skip to the end of a current iteration. So if we want to, if we want to look at all of these values, but we want to skip anything divisible by 2, 3, 5, or 7, we print that, and then you can see that kind of gives us somewhat of the prime, like we get some of that. But basically, this allows us to skip this iteration and then move on to the next one. So you don't see 2, you don't see 3, you don't see 5, you don't see 7. You also don't see 14 or 16 or 18 or any of these numbers. You don't see 21. We're just continuing past all of those. Now, one last point on loops. In Python, you have this else. It's not very useful in practice. You won't use this very frequently, but basically the else executes when the loop is done. So this loop is done, and you can see here, once we're done, we're outputting this particular value. Now, if we break out of the loop, the else statement doesn't actually run. So that's the one place where you can kind of use this to determine, did we complete the loop normally? In which case, we'll get the else, and if we didn't, we skip that else. If we break, you skip that else. So it works similarly for loops as well, and the same kind of rules apply. If you break, you don't actually get that last point, the last line. You probably won't ever have a real reason to use this, but in case you ever encountered it in code, it's kind of nice to know that this is the way it works. So a couple of exercises here that you can try on your own if you're interested. Next up, we'll get into different structures in Python, but thanks for watching this one. I'll see you again soon.